I keen to say good afternoon, everybody. Um, this is the talk about DevOps. So if you didn't intend to be here, I won't be offended if you walk out. You can walk out at any time, I guess, as well. Being agile about agile. So how to get the most out of this talk? There's a progress bar. I do cool stuff with PowerPoint. So basically, when I put this up, I thought maybe everybody could get excited about the talk. At this stage, I think most people actually just want to go for lunch, but that's cool. We added a cat picture at the end, so everybody would feel happy. Or if the talk sucks, you know how long to endure. Ignore the tooling. I think that's important with any conversation around DevOps. There's multiple tools, there's multiple ways to go about doing certain strategies in DevOps. I'm using what we use because that's the best fit. It's what we've built our stuff on. And then engage. I think it's important because as the talk's title says, it's about collaboration. So whenever you guys feel that you want to jump in, please do so. Okay, so who am I? I'm Lowe Richter. I'm a change instigator, DevOps enthusiast, and I work for DVT. There's a couple of places you can find us. Who here has heard of DevOps? Who's actually doing some form of DevOps? Okay. The definition on there is the definition from Microsoft. So it's DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. The keyword there being value. So how do we define value? I think it's actually become evident throughout today that a lot of people struggle to figure out what value means. In the end, it's basically just return on investment. Spent R1 on development, I need to get R2 out, or I'm getting 50 cents out. So for those of you that doesn't have a background in dev, what is exclamation value? Exclamation being not value. Software not delivered, software not delivered on time, software delivered but not function as expected, software with defects, software developed on spec, in budget, on time. So that last one, I think, in the agile world, we know that that doesn't actually equate to value. It looks like it could have been value, but in reality, you can deliver the best product that you planned 2 years ago, and it's not market relevant anymore. So it's definitely not value. The only real value, if it doesn't reduce cost or increase actual money coming into the company, it's not really adding value. So I think that's key when embarking on a DevOps journey, is to figure out what is the value measures for your company. If you're building an internal system, it should be something that reduces and enhances capability for the company. We need to continuously innovate. So like Henry Ford stated there, if you ask the guys what they wanted, they would have said a faster horse. Okay, so it's a lot of talking, but brace yourself, DevOps is coming. So in essence, this is the idea of a DevOps lifecycle. So shorter increments, more frequent releases to production. And that basically means that we can then validate any ideas. So it'll be foolish for us to think that we're going to go into a development cycle for a year and then release something and then nobody likes the product. So in essence, DevOps tries and aims to actually reduce those cycle times, therefore increasing some value. So this is in VSTS. We decided for us to get more frequent releases, we need to release from one place because you can't release from a developer's machine. So we decided to put up a continuous integration cycle, which was cool. Now we're going to make money, right? The problem we have is that alone didn't do anything because it actually just made sure that we now have a package that we can deploy more frequently. But deploying the thing was still a bit of a problem. So we decided, okay, cool, we need to now focus on the other axis of this graph, and we need to just start deploying more frequently with automated tools. So we decided to build in a release pipeline. Now we're making money, right? But then, if you think about everything we said, something starts creeping in. Instead of people developing stuff, they start fixing stuff. Now, I know this is a fallacy because developers never write bugs. I'm one. So I don't even know who would draw a picture like this. And then we start burning the budget. We don't, at this point we know something is wrong, but we can't quite put our finger on what is the problem with what's going on. Is it a fact that we're ignoring something that's so blatantly obvious? Or is it because it's something that we can't actually see? Now, in my experience, it's probably because it's something that we can't express. So we understand there's a problem, but we don't know how to address the problem because we can't present the problem. And this is typically where communication falls down. People say, well, we think there's something wrong, but the reality is, without data, it's just another opinion. Therefore, we then decided to go into tooling, which helps us actually showcasing some of those issues. We decided to go for SonarQube in our development practices. Now, what's nice about SonarQube is it actually gives you a list of stuff that's wrong or that potentially could go wrong. And it gives estimates on days. Gives us some more detail. But now we're just showcasing the problem, right? How do we address it? That's the actual concern, because nobody would give us a sprint to go back and fix technical debt. Again, it's that same picture. The reality of the fact is we need to tackle technical debt today. So you need to, in the DevOps cycle, continuously tackle debt. And that's the key that we found that worked for us. If you don't do that, you'll end up having that incremental approach. So this is typically a graph that we have. And if you can see there, we're actually going on a day-to-day basis. We're reducing the technical debt. And that's the only way to deal with technical debt. Technical debt is a detriment to everybody else. It's one of those things that we as developers struggle to communicate that to management. We go to management, we say, listen, we have this technical debt issue, and all they say is, but you created it. And that's typically where most people get stuck. So what now? And I think this is something that was key for us, and I thought it might add value to the guys here if we end up having a discussion around how do we display technical debt, how do we prevent it from actually exponentializing and then eating down into development time. I see I did rush the talk a bit. I hope everybody did follow, but I'm hungry, so any questions? So the question is, I'm not sure if everybody can hear, but the question is, did we plan capacity in the sprint for technical debt? The reality is, no, you can't. People don't actually like that. That's why we had to adjust our cycles so that we continuously improve. So as you release something into that pipeline, it continuously checks quality. And then right after you checked it in, it'll show you your quality, and then we address that quality issue right there and then. So again, it's not on an iteration based, it's basically on a daily. So typically most developers check in at least once a day. That technical debt would probably be amounting to something like 30 minutes or so. That's the average we found per day. If you accumulate that, it actually gives you that curve. But if you tackle it that day, the knowledge is still fresh in your head. The report will probably show you more or less what's wrong. Then you can tackle it there and then in like half an hour. So on integration, when there's technical debt, typically, so yeah, that is a bit more difficult to address. But typically, we actually allow a little bit of time, slack time that they discussed this morning in the talk as well, to allow for these types of issues to be manufactured. But the question is not, so when it comes to integration, is that technical debt or is that just communication that's added onto the complexity of integrating? I'm not sure. So typically when you use the tools, it's technically technical debt. So it's not bugs, it's not any of that stuff. So a bug that comes back is not usually treated as technical debt. Technical debt is one of those silent killers. A bug would account to unplanned work because you wrote a piece of software, you want to deliver it, but you can't. So that Sonar Cube tool will measure technically. So if best practices in coding, it won't, and that's usually where a lot of stuff falls flat. So you for example, don't handle an exception message, so the user doesn't know what's going on. The tool does not know business logic, and that's typically where the bugs would come in. How do we collaborate with infrastructure? So that wasn't covered in this talk at all, but from a DevOps perspective, that is typically one of those things where that's the real, if you look at dev and ops, the ops side is the infrastructure guys as well. So we build most of our stuff in the cloud. We've got guys that are expertise in that, but they're part of the team. So you start planning with them as you go into any cycle, more or less what it is that you need. We start building out those pipelines. So those release pipelines I showed you, they form part of what those guys want as well. I think initially the problem is it depends on whose side you look from in terms of DevOps, because there's this big notion that it means no ops, and that's not true. You'll always find guys that know hardware better than the developers themselves. A lot of developers don't care about hardware. If you build that pipeline out, that means that now you're collaborating between development and operations. They would understand how stuff flows through that. So typically the resistance is there, but it's from both sides actually. So with legacy systems, it'll pick up all of the debt that's currently in the system, right? the idea would then be not to add more debt onto that. And as you go, you can also look at that report and then start reducing some of that technical debt, either by putting it back into the backlog, but that's a difficult sell, or just doing the right thing. When you're deving, you're touching something, you see that there's a potential increase here, we reduce technical debt, we push it in. Yes, yeah, exception handling is definitely one of those things. I'm not sure in what context you're talking about, but if you're not raising exceptions to the end user, to some extent, because obviously you need the nice way to handle that is to with a framework that'll make it a nice human-friendly message, because just throwing an exception also puts the company at risk because it might expose some details. Yes, yeah, not handling that is technical debt. Yeah. Sorry, you've been waiting a long time. I've been ignoring you like unplanned work. So how would they know technical debt exists? Yeah, but the problem we have as techies, we need to, so the product owner won't know about that type of technical debt. The product owner is not meant to be that technical. If it's a deficiency product-wise, it'll be listed as a bug probably, and that's something that then becomes part of the business domain. And it's less of technical debt, but more of an actual issue. So typically in the past, it was addressed by developer reviews, but the problem we found is that by the time that so doing code reviews on a continuous basis costs even more. It takes a bit longer, and the problem is that a developer might miss something because he's biased towards, it's fine if we leave that exception handling open, for example. So in the past, it was more, we know that there's a problem down here somewhere, but we don't know what. This tool actually just helped us visualize it. And that's typically the whole approach of DevOps as well, is to first visualize and then try and figure out how to approach fixing the issue. So previously it was all just opinion. The tools help, yes, but it doesn't have to be that specific tool. But it's a similar thing when you start talking about automation testing and that type of stuff. Doesn't matter what tool you use, but you need to do automation testing at some stage so that you don't miss that. If you put too much manual labor into something that is repeatable, it means that you're going to miss stuff. And that's typically where tools help. It doesn't have to be that tool, but tools help. So that was a question that was somebody else asked earlier as well. What do we do with the existing technical debt that's in the past? Typically, as you go through coding, if you enable Sonalint, for example, on most of your tools, it'll also highlight while you're busy working on that page what other issues were picked up in the past. Then you just fix them incrementally. And as you go, the system will get better. The reports will show they get better. Therefore, at some stage, if it's bad enough, you can probably advocate to have some time to fix technical debt. But that is a way more difficult sell. But at least by visualizing it, it'll get you closer. Yeah. Donovan Brown from Microsoft said it best. You don't have to ask permission to do the right thing. Any other questions? Thanks, guys. I think that talk of mine was way shorter than what it was meant to be. But I appreciate everybody participating and engaging. And if there's any more questions, we can chat over lunch.